So today I wanted to talk about Springfield Phantom 1 valve rockers. And of course these are the devices that are on top of the cylinder head that pivot up and down and open and close the intake and exhaust valves. And the aspect I want to talk about is this directive that was in Springfield literature, and it explains that the oil hole that allows oil to come out and lubricate this area and the top of the valve stem was causing problems with over oiling, and it was fouling plugs and just putting out a lot of black smoke. So they suggested to block these off. Don't allow the oil to come out the ends. And they said that later ones would not be drilled through. And they did have a partial drilling because they wanted to keep the weight down, which sounds kind of silly considering how heavy the cars are. So they put out this directive, and this is something I do not agree with. I have encountered some cars that had a significant amount of wear on that area of the valve rocker. This one's not too bad, but that shows you where they'll wear. And this one is plugged but not drilled. So, but I have seen some that wore considerably to the point where they accumulated filings around the plate for retaining the valve spring. And that is because of a lack of oil. I've even had some that would make a squeaking noise when they would open and close. And that certainly is not acceptable at all. So now these rockers, I had them refaced to get rid of that wear, because when you have a divot wear there, you can't get an accurate reading with the feeler gauge going across there, because the feeler gauge is only going to read the high spots and not the low. So then you're going to be loose. And again, loose is better than tight. Tight will burn valves. Loose will make noise. So you always want to, when you have these apart, face that down, and you have to remember that that is it has to be swept across. I have a machine shop that does this for me, and they do them so quickly and so inexpensively. I just let them do it. If I didn't have them, then I'd have to make some sort of a fixture that would sweep it across a grinding, a rather large grinding wheel. But luckily I have them. So yeah, so now here's one that I did. Actually, I did two of them. So I put a brass cap in. When you see any of the other ones, it's aluminum. I just think brass is easier to work with. I drilled the hole. I don't know if you can see in there or not. So I drilled the hole. I use a drill bit that's slightly smaller than 3/16. This is a 3/16 hole. And also, you have to be pretty selective about your drill bit. You have to remember, this is a forging. So in that right, it's hard. But then they heat treated them and they made them even harder. And when you're drilling through something that's rounded like that, it causes an interrupted cut. And hardened things such as carbide and things of that nature, they don't like interrupted cuts. They want to, they'll do very well cutting through a solid piece. But when you have an interrupted cut, even when you're machining, when you're doing work on your lathe and you have a carbide tool, and when you're doing your machining, if it has an interrupted cut where it's just hitting something, even if it's a soft material, a lot of times it will crack and break that carbide. And that's the same with the drill bits. So I tend to use an HSS drill bit, a high-speed steel drill bit, because that tends to have a little bit more flexibility at the tip. A lot of times you'll go through a couple drill bits when you're doing a set of these, but it is something to keep an eye on. And also I want to point out, and actually this is an accurate drawing. So you have one hole going this way and you have one hole going that way. So you have to drill through going this way. You can't just drill through completely or you'll mess up the rocker. So don't think you're going to cheat and drill through this way. Just consider the fact that you have to drill through there. So yeah, so I put the brass plug in, and also in here I like to put segments of felt. So I hammer out a couple pieces of felt. I use a punch, like a paper gasket making punch. I usually do 2. So then we have these little chunks of felt. This is a hard felt too. And the diameter of this cutter is 3/16. And then we can put that down in the hole after it's been drilled, of course. So we feed those in there, and then I just make up some pretty simple little brass caps. I just cut these off, simple enough with a hacksaw. This is 3/16 brass tubing. I don't worry about finishing out any of the burrs or anything. I do that after I get it fitted in there. Then you can use a Scotch-Brite wheel or something to face off the end like I've done there. And then I normally drill that small hole. It's going to be something like between 20-30 thousandths. So I usually drill that small hole after I get this plug in place, and that's sort of the last step. So now this was a practice. So this is a 2025 rocker. So yeah, so it had the hole there, and all the other pre-war Rolls-Royces and Bentleys have the oil hole and the oil coming out. So now the felt inside of here keeps it so that the oil doesn't come squirting straight out, so that it'll kind of ooze out and then come around and keep this area well lubricated. So yeah, so that's what I've learned with these. And again, you know, usually the information is what you really want to follow, but under these circumstances it's not. And there's other things about the valve rockers I'm also going to touch on, but for now we're going to move over to the drill and drill these holes. Okay, so we're over here at the Bridgeport, and we're going to drill this hole out, as I had stated. I'm just going to show you my method for getting this set up in a more of a painless manner. So I already did one, so things are kind of close. But yeah, I'm going to stick it on the bit like that, and then that's going to give me my positioning. And again, this is an undersized from 3/16 bit. I'll tell you the exact size here in just a minute. Okay, it is an 11/64. Whoops. We're going to get a little cutting oil in there. Now, initially, it'll seem like it's drilling and without too much work or effort. But then once it starts getting near to the breakthrough point where it's going to be an interrupted cut, it's going to be harder there, because a lot of things that have been heat treated are harder on the surfaces than they are on the interior areas. And so that would be considered a surface, because it was probably already drilled this way when it was heat treated, so then the heat treating was able to go around all those areas. And you can hear the drill bit working on it, because, you know, again, it's trying to get my arm in the way here. Maybe I can change the angle of things a little bit. So you'll hear it struggling to get through. It might even get a little squeaky at the end. Clean out some of the filings. Getting hot, so we're going to add a little bit of more oil to help with that breakthrough area. And there it goes. So we'll do another one in case you missed it. Sometimes they vary a little bit from one to the next, so sometimes you have to shift things a little bit. So again, it's starting off with a nice easy cut. Okay, so now we're starting to hit the hard part. Help it out with a little oil. Okay. So now we have these two drilled. I believe our drill bit is still alive. Just looks a little slimy. And we'll clean these up and move her back to the bench. Okay, now because of that drilling, we have a little burr in there almost always. And you'll notice that the concentric bushing, you'll notice it's thicker there than here, will not go in because it's hitting that burr. So we got to get rid of that. Normally what I do is use a, what size is this? 13/16 reamer. And I just very gently run that in. Sometimes I come in from the other side because we just want to take out the burr. We don't want to cut any other part of it. And always remember, when using a reamer, never rotate it backwards. Always rotate it clockwise in the cutting direction. Rotating it backwards will dull down the reamer. So I normally take a little bit out, see how it feels. Maybe it's the other bushing that felt a little better. Yeah, so there's still some in there. Huh? And then you get a nice fit. So now once you have that accomplished, we can put in our little segments of hard felt. And now we can put in our brass plug. I normally need to do this with the aid of the vise. So that one seems like a very loose fit. Sometimes the holes are a little larger than than what they were supposed to be. So then what I do is hammer out the plug a little bit, mushroom it out. So it's a much tighter fit. Once you get it started, you can put a little drop of Loctite on. Whoop. Came out faster than I had planned. I normally leave it just a little bit proud. You can then peen it around some to make it an even tighter fit. Then we can dress this down on a Scotch-Brite wheel. Make it look pretty. Okay. And then lastly, we put our small 20-30 thousandths hole in the end there to allow the oil to come out. Okay, so we have our teeny tiny little drill bit set up in a teeny tiny little chuck. And it's nice to have, when they're this small, I like to feed it in by hand, and in this method you see it's at a little bit of an angle, so I'll straighten it out and then we'll just make teeny tiny little chips, And we'll let it drill its way through. And again, like with any drilling, it's the critical spot is usually the breakthrough on the other end if it is a through hole. So there we go, we're all the way through now. So now we have access for the oil to come out. So I plan on doing more videos on Phantom 1 valve rockers, but I did just want to touch on a few important points here. They have a rather interesting adjustment type mechanism, and it involves these eccentrics, and it has a little worm type gear on there, which is supposed to engage with the little worm on these screws, and then that turns the pivot point of the concentric. And a lot of times these get damaged. Not only these parts, but these as well. This is what they're supposed to look like when they're in good shape. This isn't very clean, but... And I thought I had a bushing here that was... Oh, here it is. And this is one that has nice teeth on it in order to engage. So yeah, so people, they don't quite understand this mechanism a lot of times, and it gets abused. Now there's another version of that adjusting screw and all. I don't have the concentric part of it, but there's this type as well. So, you know, there's two variations. You got to know which one is which when you go for a replacement. I forget the chassis number cutoffs. But what had happened a lot of times is before you can adjust your rocker, you have to loosen up these two nuts. You have one on this side and one on this side. You also have this middle one that's pinching. And so you got to loosen those up before you can turn this screw. Otherwise, everything is locked up, and the purpose of locking it is to keep this adjustment from wandering. So once these nuts on the end are tightened down, then these can't move anymore. But people try to make them move anyway because they think that they just need to turn those to adjust them. So you have to be very careful with that. And again, I think this is all explained in the handbook or in the service instruction sheets. So read that very carefully and understand how this mechanism works before you go and ruin these parts, because they're expensive and they're not easy to make. And I'm sure you would prefer to not have to go down that road with it. So keep that in mind. And also, again, if you have a heavy amount of wear on these, it really needs to be dressed out. Also, the whole shaft in the middle is hollow and it has oil holes, and they need to be cleaned out periodically. You got to take this plug out of the end. A lot of times they're soldered in. So unsolder them, and then you can run a rod in there and clean that mechanism out. But it's really quite a neat mechanism. Now, some may ask, well, why didn't they just have a grub screw or something like you would see on a you know, one sticking up with a nut, a lock nut? And why didn't they go with that route? And probably the reason why was because they wanted to keep a lower profile. They didn't want the engine sticking up too tall. So if you had a grub screw type adjustment, then you'd be sticking up that much farther, and then when it closed, it'd be even that much harder. So you'd need a taller rocker cover. So with this, they were able to keep a lower rocker cover. Now Phantom 2 and the later small horsepower cars, they eventually did go to an adjustment screw here. And they do have taller rocker covers, but it does make life a little easier in some ways. And this adjusting mechanism works really quite well, but you do have to be pretty attentive to them. So even after you tighten up your lock nuts, you have to go through your adjustments again and check your clearances again, because sometimes when you tighten down on these nuts, things sort of shift a little bit and some clearance can go away or become wider, and so then you need to go over them again. So anyway, I just wanted to point out that. And again, hopefully I'll be able to get to a point where I'm working on valve rockers on a Springfield or even a British Phantom 1, and we can work through them very carefully with all the details and provide you with all the information about them.